And these are the data requirements for the tube head and total weight. And for the front row hooks, I apply a force of 620 to the side, to the plates on the side, and restrain it to the same plates and to the bottom, and I come out with a maximum stress 15.7 KSI with a factor of safety of 2.7. And this is their requirement for the tubing for the engine supports and the total weight. And for worst case scenario, I apply a force of 166 to the engine supports and the engine mount, and I come out for a band misses of 50.6 KSI with a maximum deflection of 0.08 and a factor of safety of 2.7. And I am also responsible for the firewall and some safety. And the SAE requires that we apply a force, a normal force to the headrests of 200 pounds. And when I did that, the factor of safety was greater than 0.2. And this is the safety harness. And with all these requirements, I was able to come out with the data requirements. Now we'll go over the impact alternator. What is the purpose of the impact alternator? The purpose of the impact alternator is to absorb energy in case of a crash. And with all, I was able to reduce the weight for the impact alternator by 47%. And this is the total cost for the impact alternator. And these are the formulas that I use to be able to find the data requirements. What I did different for the impact alternator, I organized the materials that they have the same mechanical properties. And for the car, for our car, our main purpose is to have a lower weight. And at the same time, that will have a higher compressive stream. Because if we use kinetic energy equals to potential energy and we solve for the distance, we will find out what is the total thickness that the impact alternator will decrease in case of a crash. And this is a material that best fits our requirements. The SAE required us to do a compressive test. We use our hand calculations to find the material, and we use a compressive test to find out if we have enough energy to save the driver. Because if the total energy absorbed is greater than the given energy, we know that our material is going to work. And if once we do the compressive test, if we plot a force versus distance, if our material behaves like this, we know that it's good, because in case of the material oscillates, it can hurt the driver. I choose honeycomb aluminum because it's low on weight, it has a nested spring, requires less labor, and these are the two materials that I choose to work with. Now we'll pass it to Steven Cigano.
Good evening, I'm Steven Cigano, and I'm in charge of the rear chassis this year. So for this year, we're gonna, the purpose of the rear chassis is to have high rigidity to handle the road loads and by the suspension and the drivetrain forces. And also it should be as lightweight as possible. So we propose to make a rear monocoque out of 6061 T6 aluminum with a weight of 8.1 pounds and 8.52 pounds with the jack mount, which is right here. So for analysis, I added connectors and contact gap restraints in Cosmos, which includes the bolts into analysis, and this will result in more accurate values for the factor safety and stress test. and I used the worst case scenario, which is accelerating in the right hand corner and hitting a 1-inch wall. So for the displacement analysis, and this is on a 15.9 scale to see like how it actually displaces, I got a max displacement of 0.1 inches. And for the torsional rigidity analysis, I put a 500-pound coupling force, and the torsional rigidity I got was 4,458 foot-pounds per degree roll with a max deflection of 0.005. Using the ISO clipping in Cosmos, I was able to set the factor of safety of 1.25 and see where it actually was lower than this value. And you could barely see it, but it's only located by the connector bolts. Then I manually set the factor of safety to 5 to see what parts of the chassis was 5 times stronger than it needs to be. And you can see everywhere it's clear, it's 5 times stronger than it needs to be. So I'm coming to the conclusion that this chassis is over-designed and a lot of weight could be saved in the future. And for the stress analysis, I got a max stress of 50 KSI, and this is also seen by where the bolt connectors are. So for the cost report, I came to an estimated cost of $222.50 for the materials, and we're machining all the plates in-house. Well, hopefully all of them, except for maybe the left and right plate. And to summarize the chassis department, we're going to use an infused carbon fiber monocoque, which is hopefully going to be 25% lighter, aluminum rear monocoque, a 1-piece impact attenuator, a carbon fiber headrest and firewall, and a 4130 chromoly rotors. And our total department weight is expected to be 78.31 pounds, which is 2.3% reduction from 2008. And our department cost will be $4,250, mainly coming from the CNC of the female mold from the front chassis. And that concludes our presentation. Next to present will be the suspension.